Let's start. A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Assalamu alaikum, dear students, and very good morning to you. Today we shall discuss about coordinate geometry. Coordinate geometry, a very important chapter in class 10th of mathematics. In coordinate geometry, we usually discuss Cartesian coordinate system. Cartesian coordinates means two lines, we call them x-axis and y-axis. These are two line segments mutually intersect each other at right angles. The point where these lines intersect each other is called origin. And you see here four quadrants are formed. This is called the first quadrant, and this is second quadrant, this is third quadrant, and this is fourth quadrant. In first quadrant, both x and y coordinate, x coordinate and y coordinate, both are greater than 0. That is, x is greater than 0 and y is greater than 0. X coordinate is also called as abscissa, and y coordinate we call it as ordinate. And in first coordinate, both are positive. Positive means that they are greater than 0. So these x is greater than 0 and y is greater than 0 in first quadrant. Then as in second quadrant, x is less than 0 but y is greater than 0. That means when we move towards left of this x-axis, these are negative, x is negative, then obviously y is positive. And in third quadrant, x is less than 0, that is from x I mean x coordinate, and y coordinate is also less than 0. And in this fourth quadrant, x is greater than 0 and y is less than 0. So in first quadrant, x is greater than 0, and both values of x and y, they are greater than 0. And in second quadrant, x is less than 0 but y is greater than 0. And in third quadrant, both x and y are less than 0. And in fourth quadrant, x is greater than 0 but y is less than 0. So if we are asked to suppose locate this 2, 3 on this graph, Cartesian coordinates 1, this is 2, suppose this is 3, this is 4, and this is here origin, the point where x-axis and y-axis intersect each other. This point is called origin. And when we move towards left of this origin, negative sign comes, that is -1, -2, or we can call them negative integers, -3, -4, -5. This is again positive, 1, 2, 3, 4, and 5. This is again negative, -1, -2, -3, -4, and -5. Now how to draw the graph? This is positive, 1, 2, 3, 4, and 5. How to locate this point 2 and 3 on this graph? Here we see that 2 is positive and 3 is also positive. Therefore, this point exists in the first quadrant, because we have earlier on discussed that in class 9th, that when this first quadrant, both x coordinate and y coordinate are greater than 0, that is they are positive. So when we have how can we plot this point on the graph? This 2 is the x coordinate, or we call it abscissa. This decides whether we have to go left or right. Since this is positive, therefore we go 2 steps towards right. And then 3. This is y coordinate. Y coordinate decides whether you have to go up or down. If it is positive, you will go toward upwards, and if it is negative, you will go downwards. So that is it. दिस इज द मंत्र, ये आपको याद रखने की चीज है। एक्स क्या डिसाइड करता है और वाई कोऑर्डिनेट क्या डिसाइड करता है। एक दफा आपको ये समझ आ गया कि एक्स कोऑर्डिनेट ये डिफाइन करता है कि आपको कहाँ जाना है। ये इस ओरिजिन से आपको दाएं जाना है, यू हैव टू गो टुवर्ड्स राइट और लेफ्ट। दिस इज द एक्स कोऑर्डिनेट which decides this, and y coordinate decides whether you have to go up or down. If it is positive, you will go towards upwards, and if it is negative, you will go downwards. So here 2 is positive, you will go towards right by 2 steps here. Then it is 3, so you will go upwards 3 steps, and this is the point 2 and 3. This is the point 2 and 3. And if you are likewise, you are asked to plot this point 4 and 1. Both again we see that 4 is positive and 1 is also positive. So here we go. We will move towards, because this is the x coordinate. This decides that we have to go right from origin because it is positive. By how many steps? 4 steps. Here it is 1, 2, 3, and this is 4. Then y coordinate decides up or down. So it is positive 1. This is here, this point 4 and 1. Now, if it is like this -2 and 3. So where does this point exist? It exists in the second quadrant because x coordinate is minus. So therefore, we shall move towards left because x coordinate decides whether you have to go right or left from the origin. Here we have to go to the left because it is negative. So here we move to 2 places to the left. It is -2. Then 3 is positive. Therefore, we go upwards by 3 points. ये इसके सीध में आ जाना चाहिए इस 3 के, and this is the point -2 plus 3 positive 3. Then if we are asked to locate this point -3 -1. Now both these coordinates, abscissa and this ordinate, that is x coordinate and y coordinate, both are negative. Therefore they exist in the third quadrant. Therefore x coordinate again it decides we have to go towards left because it is negative. Therefore x coordinate decides we have to go negative. By how many steps? 3 steps. Now again it is minus, therefore we go downwards by 1 step. Here this point is -3 -1. So similarly, if it is 4 and -2, this point will come in the fourth quadrant as 4. It is positive, it decides we have to go 4 steps towards right from the origin. Here is 4. Then it is -2, we will go downwards. This is the point 4 -2. So dear students, it is now clear, I think, how to plot the points on the graph. X, you have to remember this, that x coordinate decides whether you have to go left or right from the origin. If it is positive x coordinate, then you will go towards right. If it is negative, then you will go towards left. And y coordinate decides whether you have to go upwards. If it is positive, you will go upwards, and if it is negative, you will go downwards. That is it. How to plot points on the graph. So if this question was asked in class 9th, probably plot these points on the graph. Now in class 10th, there is very important formula that we call it as distance formula. Distance formula. Now how to derive this distance formula? Again we take this Cartesian coordinate system, x-axis and y-axis. X-axis and y-axis, they intersect each other here. Now let us take 2 points. We have P and Q. Let the coordinates of this P be x1, y1, and the coordinates of Q be x2, y2. So these are the coordinates of this point P and point Q. Let us join these 2 points. We will get a line segment PQ. Now let us draw the perpendicular from here. It is clear already that This x coordinate, it decides whether we have to go right, how much we have gone towards right. It is from, suppose this is A, from O to A it is x1, from A to P it is y1. And similarly, suppose this is B here, from O to B it is x2, because the x coordinate of this point is x2, and from B to Q it is y2. Let us draw a line parallel to this AB. See, this is PQR. Now see, PQR is a right angular triangle. Now here OA is equivalent to x1 and OB is equivalent to x2. And what is this AB? AB is equivalent to OB minus OA, that is x2 minus x1. So AB is x2 minus x1, and similarly this PR is also x2 minus x1, because opposite sides of a rectangle are equal. Similarly, what is this BQ? BQ, this is y2. And what is BR? BR is y1, because opposite sides of a rectangle, this is y1, this is also y1. And what is QR? QR is BQ minus BR, that is y2 minus y1. So this QR is y2 minus y1. Now applying Pythagoras to this triangle, in right angular triangle PQR, this PQ square, this hypotenuse square, is equal to base square is this PR square plus QR square. This is by Pythagoras theorem. And PQ square is equivalent PR is x2 minus x1 whole square plus QR is y2 minus y1 whole square, and PQ, this is the distance PQ, this is equivalent under root of x2 minus x1 whole square plus y2 minus y1 whole square, and this is the famous distance formula. So this is very simple. Now we shall discuss the application of this distance formula. Suppose A is a point and B is another point. The coordinates of this point is 2, 3. Coordinates of point A, 2 and 3, and suppose 5 or 7 are the coordinates of point B. So join AB. What is the length of this AB? Here we use the distance formula. PQ is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square. What is here x1? x1 is the first x coordinate, that is 2. And second x coordinate, that is 5. This is x2. This is first y coordinate, y1 is 3 and y2 is 7. Here AB is equivalent to under root of, yes, x2 minus x1 whole square plus y2 minus y1 whole square. So this under root of x2 is 5 minus x1 is 2, 5 minus 2 whole square plus y2 is 7 minus 3 whole square. So this under root 3 square plus 7 minus 3, that is 4 square. So this AB is equivalent under root of, this is 9 plus 16. So AB is equal to under root 25, and under root 25 you know AB is equivalent to 5. So we can find the length of any line segment once we apply this formula, that's called what? Distance formula. Second application is, So from any 2 pointers, from A to B or P to Q, if you know the coordinates of 2 pointers, suppose P and Q, suppose the coordinates of P are 5 and 7, 11 and -3, you can find the distance, that is the length of PQ. So this is the application of this distance formula. Second is, you can find if the coordinates of a triangle are given like this. ABC is a triangle, and suppose 2, 3, or you may call it 2, 3, 4, 7, 3, 0. You can take any kind these coordinates. Then you can find AB by employing this formula or applying this distance formula under root of x2 minus x1 whole square plus y2 minus y1 whole square, and AB will come equivalent to 4 x2, that is 4 minus 2 whole square plus 7 minus 3 whole square, that is 2 square plus 4 square is under root of 4 plus 16, that's under root 20 something. And if this AB is equivalent to AC, so then ABC is an isosceles triangle. You know it. If two sides of a triangle are equal, then it is a isosceles triangle. So it is an isosceles triangle. You can check if the coordinates of a triangle are given. You can check whether it is an isosceles triangle or a scalene triangle. And if AB is equal to, suppose, under root 20, AC comes equal to something else, suppose 27, and BC under root 13, suppose, then obviously all sides are not equal. When all sides of a triangle are not equal, the triangle is called a scalene triangle. If all sides of a triangle, this AB, coordinates of A are given, coordinates of B are given, and coordinates of C are given, if AB is equivalent to AC is equivalent to BC, that is, when we apply the distance formula, when the coordinates of A, B, and C are given, if AB comes equivalent to AC and that is equivalent to BC, that means all sides of this triangle are equal. Then it is called a what? Equilateral triangle. Equilateral triangle. Second application of this distance formula is that quadrilaterals are, the vertices of quadrilaterals are given. Suppose this A, B, C, and D. If this is x1, y1, this is x2, y2, this is x3, y3, and this is x4, y4. So coordinates of A are x1, y1, and coordinates of B are x2, y2, and coordinates of C are x3, y3, and coordinates of D are x4, y4. If now again we shall apply this distance formula. AB is equivalent to x2 minus x1 whole square plus y2 minus y1 whole square. Similarly, this BC is equivalent x3 minus x2 whole square plus y3 minus y2 whole square. Similarly, CD is equivalent x4 minus x3 whole square plus y4 minus y3 whole square. And similarly, this DA, this is equivalent to x1 minus x4 whole square plus y1 minus y4 whole square. And if AB is equivalent to BC is equivalent to CD is equivalent to DA, that is, all sides are equal. When we apply the distance formula, all sides can, suppose they came equal, then obviously this quadrilateral is either a square or a rhombus. Now check whether this is a rhombus or a square. Because square is a quadrilateral if all sides are equal and rhombus is a quadrilateral if all sides are equal. Then what is the difference? The diagonals of a square are equal and the diagonals of a rhombus are not equal. Then we shall check the diagonals. What is AC and what is BD? If these diagonals are equal, then obviously AB, if AC is equivalent to BD, then ABCD is a square. Again, if AB is equivalent to DC and this BC is equivalent to AD, that is opposite sides are equal, then this is a rectangle. This is a rectangle or a parallelogram. Because in parallelogram, opposite sides are equal. And a rectangle, again, these opposite sides are equal. Now, again, we shall check here diagonals. So, in this way, the distance formula can be used to find the distance between 2 points, or you can say that to find the length between 2 points, suppose P and Q. This is the application of this distance formula, very important. And then you can also find the types of triangles. What are the types of triangles? If whether it is a scalene, whether it is an isosceles, whether it is an equilateral triangle. So similarly in quadrilaterals, you can check these quadrilaterals, which type of quadrilateral is whose vertices are given. Then after this distance formula, there is, inshallah, we shall discuss tomorrow that is section formula. First of all, we shall the questions pertaining to this distance formula. We shall discuss them inshallah tomorrow. Distance formula, the questions pertaining to this formula, we shall discuss them tomorrow. And also the section formula. And the question, what is section formula, is actually, if this is, I will briefly introduce this section formula. If AB is a line segment and this point C, divide this line segment into two sections, or you can say two parts. You have to find the coordinates of this point C. So this is the section formula. Inshallah, we shall derive this section formula tomorrow. And also find the application of this, how can we use this section formula. Inshallah, tomorrow we shall discuss all these things. Till then, Khuda Hafiz.